So let us start this session with the introduction of Dr. Raghavan sir. It is an honor to introduce Dr. S. Raghavan, retired professor in higher administrative grade and a distinguished visiting faculty at N.I.T. Trichy with 40 years of teaching and research experience. A leading expert in MIC, RF-MEMS, BioMEMS and Metamaterials, he has published over 130 research papers, 99 IEEE explored publications, has filed 3 patents, and successfully guided 16 PhD scholars. He is a proud scholar of IIT Delhi, having established a state-of-art microwave laboratory at NIT Trichy and received the Best Teacher Award twice. Beyond academia, his contribution to biomedical research, cancer treatment, and COVID-19 solutions are remarkable. He is a senior member fellow of over 20 professional societies and has chaired global conferences and authored a recognized book on microwave integrated circuit design. His passion and dedication have shaped microwave engineering education and has inspired generations of budding microwave engineers like us. Now for the today's talk, he will be delivering a talk on microwave integrated circuits, component and design essentials, which is the backbone of modern microwave systems. It is a key to our country's remarkable achievements in space sector, defense sector, and biomedical engineering sectors, powered by the mantra of miniaturization. This lecture will cover essential aspects of MIC design, including layout fundamentals, coupled mode theory, S parameters, even odd mode analysis, CAD techniques, and more important topics. So before moving ahead, I would like to add that Dr. Krishna Kant Varikunthala, a PhD scholar under Dr. S. Raghavan, has won the prestigious Young Scientist Award at URSI Commission EMTS 2025, and he will be honored in Bologna, Italy from June 23rd to 27, 2025. So I hope we'll get a chance to learn about this award-winning topic, reconfigurable plasma frequency selective surveys from Dr. S. Raghavan. And with this, I would like to hand over the presentation. So sir, over to you now. You may start sharing your screen. You may please start, sir.
Okay, thanks a lot. Oh, this lecture will be dealing on microwave integrated circuit components, design essentials. In that, I feel this may not be a kind of a regular kind of lecture, but certain salient points I would like to bring out. And I would like to request all the participants to start sharing in the conversation. In the chat box, you freely express whatever you want to write. Maybe after 1 hour, there's a break. Then we will definitely discuss about for 5-10 minutes. Then I used to ask a few small questions. That also you please answer. So let us have the kind of discussion through chat box. You feel free to express everything through chat box. We shall definitely discuss about it. And this is just for those who know all the subjects. It will be like a revision with few new photographs. And those who are starting, and this is mainly for the from the basic fundamental. And I am of the principle that research scholars, students should not directly go to the commercial software. They should become expertise in Python or Google, like that, MATLAB, like that. Then at the end, they can go for the testing. With that, I will start. So the basic principle is, at the end of this talk, definitely all of you will be able to, all of you in the sense, those who are at the starting point can definitely design and draw the layout. The layout is very important. Up to the third decimal of millimeter, it should be correctly drawn. So that's what you are seeing in the right side. In the left side, with this is a different kind of Smith chart drawn on JPG basis, printed on the cake, and this can do almost 80% of what a network analyzer can do. as far as the design alone is concerned, not the analysis. So this is that much powerful. So we will amalgamate these two and then see what the MIC component design essential is. And I call her as the goddess of MIC. It is not myself alone. Throughout the world, I will show God of MIC, also microwaves also. He is from Japan, and this Professor Bharathi Bhat has written more than 8 publications. Whatever is working in the lab will come as a book. Whatever is in the book will be directly can be used even up to the defense level. All of you should definitely go through, enjoy the publications of this Harvard returned simple lady who is very nicely, aptly described by Professor Abdul Kalam. And this is our world. Every circuit is inside. Maybe we have got only 10 components. You can make it in a different combination. You can have it in the variants. And I will tell you, or you yourself would have felt, the easiest subject is MIC design or MIC lab, and also the subject for which people are afraid of coming. The main reason is of Maxwell's equations, and there is no need. Without Maxwell's equations, we will see that for the design, one transmission line equation is sufficient. And I would like to dedicate this to Mishra. Why I am dedicating that, I will tell afterwards. Now only people keep talking ANN, AML, DL and all. 30 years before, this Mishra of Berhampur University, along with another person from IIT Roorkee, they have given a very good paper, ANN microwaves. That time only the other important Bible from K.C. Gupta and Zion on ANN microwaves have come. And the leftmost is a person, young person, but is the person who has done lot of work on textile antenna. And everyone knows, being a Kharagpur student, you know, third person Dr. Guha, and the last person Gaganyan, important person, ex Vice Chancellor Surendra Pal. Center is also a Vice Chancellor Patnaik. And this is true. A lamp cannot light another unless it continues to burn its own flame. A teacher can never teach unless he himself continues to learn. That you can see from living JC Bose. I will show you who is living JC Bose. And you all should be proud, especially IIT Kharagpur, to feel proud of the contribution of JC Bose. These days, even now, we struggle if any frequency goes more than X band. We find difficult in the lab if it goes to Q band, K band like that. This J.C. Bose has played with millimeter waves. Not only that, he has done a lot in zoology, botany. He is supposed to be, not supposed to be, he is the father of radios, millimeter waves, then metamaterials. Many, many things what he has done, people may not know it. You just go through all the things, whatever he has done. These are all the universities. This is what I want to tell. He's living J.C. Bose. Even at the age of 82, he keeps deriving. He can be told as the father of microwave tubes. J.C. Bose, so many things he has done. You should call him and see. Not only that, he has written a book on plagiarism, how to write thesis paper, many more things. So I have made this name recognized by in a larger section as the living J.C. Bose. And I should definitely thank all this group, especially Ankita, Viswas, and Viswadit Roy, and all other people. Why I am showing is, I will show you another set of people 100 years before. So definitely after some 100 years, these people will be pronounced by many people because they are doing wonders. And right side you can see Dr. M.K. Mandal. I would like anyone to give in the chat box who is Mandal's PDF guide. One clue I can give is almost a young person only, but he has done a device which bridges waveguide and planar transmission lines. And under him only he did the PDF. And I hope some of you would have typed in chat box who that PDF guide of Dr. M.K. Mandal. And this is what I already shown present group of IEEE branch of IIT Kharagpur. IIT Kharagpur plays a very big role. There's ISRO Gaganyaan engineer listening here, Dr. Professor Mahadevan. His alumni is IIT Kharagpur. IIT Kharagpur has done lot for microwaves. If it is a microwaves, it is IIT Kharagpur, radar. If it is a biomedical, IIT Bombay. Like that, there are things. So now you are finding another group, Now the group whom I showed, young people, they will be worshipped like this after 100 years. So now why I am showing this is, many of the persons go by a shortcut method, directly going for the software, finishing it off, giving different name because of the different results. Even the frequency, they say after the results, random results. Now, IRE formed in 1912. Before IRE, AEEE formed 40, 50 years before. The merging of that in 1963 is present your IEEE. Why I am spending 2-3 minutes in IRE is, most of the theory, what people have found, invented, discovered, it came as a paper. For example, coplanar waveguide, CPW, his paper in 1969 is the one and the only mantra, one and the only book which you can take in as a reference. You know about the stability factor. We call it as a Rowlett stability factor. Rowlett paper is during 1935 to 1945. So all of you should go for the references. Then go step by step. Then so much of real research work will come, better than China, South Korea, all those people. So that's why I'm showing this IRE. Now, he is the youngest person, 82 years person, J.C. Basu. You should see what all his contributions. Go to the website and see. And the leftmost is one of the few physics professors in India whose anechoic chamber is very big. He does a lot for metamaterials, MIC, antenna, many things, Professor Subramaniam of antenna. So he is said to be God. He is called, everyone knows, T. Ito. He was the only person whose paper stands first, number of papers stand first in the world is Ito, Tachi Ito. And I call him as god of MIC, the goddess I already shown. And even present metamaterial Bible by Callas and Ito. Ito is the person. Very recently we lost him. So everyone would have seen, especially those who want to write a overview paper, should definitely see what is the overview of planar transmission lines by Ito. That is how a overview paper should look like. So many may be knowing Japanese. In microwaves, Indians stand first, Japanese stand second, Chinese stand third. I am sure that many of the persons, stalwarts who are in this meeting will agree to my real sentence. And these are all important things. Necessity is the mother of invention. Poles and zeros are the lifeblood of the network. Our eyes stop wherever there are ups and downs and curves. There is a plenty of room at the bottom. And necessity is the mother of invention. Many things came during the Second World War. They wanted a high power oscillator. That's why Hull and Alcatov and Hartree came out with a high power magnetron. Then many of the things came accidentally. You know about what happened to Archimedes, gun diode, gallium arsenide. gun GUNN was keeping on slicing. Suddenly he found high frequency power. That's how gun diode, many things, including popcorn. Because of the popcorn, a small uh, particle fell on the magnetron. Then it became like a popcorn. That's how this microwave magnetron. Many things came as the necessity, as the mother of the invention. Many things. You can list it out. Poles and zeros, antennas, network theory. See, in the IRE, one of the president was Gulliman. All of you should read Gulliman book, Weinberg book, so much of book. So Gulliman will say why poles and zeros are the lifeblood of the network. Not only network, digital signal processing, antennas, it is needed. Then the last fourth sentence, I hope one of you will type in the chat box. This sentence only made a person get Nobel Prize. This made the world to know what is microelectromechanical system, RF-MEMS, BioMEMS. I hope one of you or many of you will type who that person I am mentioning. So, see, Raython, see, you should go to the original saying. Then you will become like JC Bose or any stalwart. No directly going to typing the software and then finding out some reason. So see what is happening. Original point. Likewise, we have got SB Kahan. SB Kahan, he has found slot line, but many things he has done. Slot line, how he found? In a lab, he simply unfolded the coaxial cable. That's why slot line is supposed to be like a cable divided, unfold. So the properties of a coaxial cable, many of that the slot line has got. It has got a non-TEM mode. Then these are not the history. These are all the fact. That's why I compare microwave integrated circuits or microwaves to Geetanjali. I don't need to tell Calcutta people why Geetanjali is referred here. It is always fresh. None of the things found 100 years before become obsolete. Now people talk frequency selective surface. FSS didn't come now. It was the patent of Marconi. But now people are all doing lot of work. I feel proud. My last scholar is one of the very few in the world. I can say he will be one among 12 or 15 in the world. Lot of things. Now we got, I should thank Triple I, Triple E, IIT Kharagpur for recognizing his latest wonderful award. So these are the different things happening. 1940 again, when so many small devices come, how to integrate with waveguide. Then only, in fact, 1935 to 1945 said to be the golden era of microwaves. Then only came all the planar transmission lines. Semiconductor devices, the Vedam, the Bible is Watson. There is no other book which gives concise material than Watson. Then first one, stripline came, Barrett and Burns. Then microstrip. So however, how many may be the number of lines? Maybe 72 planar transmission lines. It is all built after five planar transmission lines, either elongated or inverted or V-groove like that. So you don't need to mug up what is the property of each planar transmission lines. If you know what is the mode of propagation, that you should be thorough. What is the TEM, what is the quasi-TEM, what is the evanescent mode, non-TEM, EH mode, hybrid mode, all those things you should know thoroughly. And many know it, but you should understand it. So now you should categorize. Each planar transmission line belongs to which mode. That mode property you keep writing. Then this is last one, KU. KU is the PDF guide of your mentor, Dr. I have shown first, M.K. Mandal. He only bridged the planar transmission line and the waveguide. So these are all the cross section of all these things. Each transmission line has got one Bible. You should go through that. And also, I feel very happy and proud that three, four good books. The one and the only good books are written by Indians, maybe from Kharagpur, K.C. Gupta, many things like Slotline. I will show you all the authors. Planar Waveguide, there are two books. One is by Wolf, other is by Oren Simon. Oren Simon is not from Australia, he is from Mysore. So, like that. See, these are all the giggling, these are the magical Smith chart. Smith chart, in many of the universities, you can even omit, you will get a distinction. But Smith chart is very important. Again, I feel proud that one of my PG scholar has played in with this. It is not that Raghavan is recognizing his work. The moment the microwave 101 editor saw all these things, he immediately sent his appreciation letter. Every one of you should see, if you have not seen, Microwave 101. Many things you will come to know why, where, how. If I ask why K band is K band, Q band, car band, like that. You can, yeah, not only that, why antenna distance, anything. If you want to know why, where, how, refer to Micro 101. Not only referring, if you come out with new things, intimate me. I will send it to Steve. He will put it in Microwave 101. It is a ready reckoner, and you will come to know why, where, how, all. Either in Kharagpur or America or Bangalore, there are only two types of connection: series, shunt. And Smith chart, go clockwise series, it is series L. Go anti-clockwise, it is series C. Now do it reverse, you get susceptance C, susceptance L. There is nothing other than that anywhere, any place for any of the application. This is your thumb rule. Later on, when you go and design amplifier, oscillators, or anything, it should come like that. That is why we should feel proud what ISRO people is doing, what is BrahMos is doing, what our defense people is doing. Nothing like minimum. It is zero or one. One is the thing. People see in the Republic Day parade our capacity, capability in microwaves. And the mantra is miniaturization. When you want to have miniaturization, MIC is the only solution. And now, all this game, the center one is 3D Smith chart, compressed Smith chart. Left is impedance, right is admittance. Join both, you will get emittance. Then, if the reflection coefficient more than one, corresponding to Barkhousens criteria in the low frequency, you get a compressed Smith chart. I will show you a person who did it in 2 days, where there is a will, there is a way. There are 10 commandments. That's another Bible, Levergetta. Levergetta gives 10 commandments in the first page. That if a person understands, microwaves are simply a child's play. These are the books. Again, see, written by K.C. Gupta, Amarjit Singh. This was my reference book in 1978. And there are some materials shown in this which no other book has given. And Amarjit Singh Gupta was the founder of Siri Pilani and a very close friend of J.C. Bose. You should see this book. Next, during my period, only one book was there, Harvey book. And the next one is Harrington book. Harrington was the guide of your Tapan Kumar Sarkar, who has written this book, History of Wireless, Tapan Kumar Sarkar, with so many other people. So the tallest person is Tapan Kumar Sarkar, and many Kharagpur people are here. Person who is giving me the award is the ex-secretary, defense secretary. These are the things. See, I am showing so many circuits, so many planar transmission lanes. Whatever I am showing, the method of designing, method of layout, I can finish it off in 10 minutes. That is the real theory behind that. There is one equation, input impedance, and everyone will know that, but I will just stress the importance of that. Then we use the lambda effective. Lambda effective is equal to lambda naught by root of epsilon r. So you either find, if it is a pure transmission line, use epsilon r. If it is not pure, use epsilon effective. Other than waveguide and strip line, all are impure. You should definitely find out epsilon effective. You can easily find out using full wave analysis, epsilon effective. That's all. Then I have written a paper, Miracles of Lambda. With lambda, you can do everything. People know lambda by 4, lambda by 2, lambda by 8. There are many more lambda, 0 to lambda, infinite lambdas are there. Each lambda has got some purpose. Here you can use, you can see one metamaterial also. It is called filter plus antenna. That is again done by one of the Kharagpur alumni by name Alphonse Swami. His student, a Chinese student, has done in NUS, Singapore. Then you can see SIW. SIW formulated by KU, you can see in leftmost. That's the ring resonator. Everything is there. Only the method of layers are different. Lambda effective is different. Lambda is different. Otherwise, thing is very simple. Isn't it? You can see patch antenna. Isn't it? Z naught square is equal to ZS into ZR. If you know the equation, you can easily find out what is the length, width, everything. So almost all the things I am showing here, will go for the design in a very simple way. This is the thing now. Nobody bothers what degree you got. What is the how many number of publications you got? I feel proud. My citation is the highest among all 32 NITs in circuit branch. Anyhow, publication is very, very, very important. In that, I would like to say, because of the facilities available, Indians are lacking in the number of publications. Go to South Korea, go to China, their publication, their facilities are sky high. That's why their kind of publications are little different. But soon we will reach that also. And these are the people who are these are the now Ankita. This was the I know that a vice president like that in IRE. H.A. Wheeler, Gulliman, then Harley and Ho, then popular S.B. Cohen, then Hewlett Packard, uh, then most importantly this P.H. Smith. You go to their history and see how they slowly came, how they accidentally they came out so many things. You should know about the Wheeler's cow. If you do not know about the Wheeler's cow, getting W is very difficult. And a microwave person should not directly go for a microstrip calculator, CPW calculator. You should not go. You should create calculator. So these are the Jambawans. These are the people, office bearers of IRE. And only one sample I am showing. This is Arunan. He was the project director of Mars mission. At the first attempt, India won. And why I am now and then telling ISRO people is, see, satellites cannot get launched unless the weight and volume are less. The weight and volume can be less. The backbone of that is microwave integrated circuits. Now, the other name for microwave centimeter wave, we talk about micrometer, millimeter, so many things. And our MIC play a very big role in the all satellites. And this is the first thing. Again, this was done by in 2 days by one girl, PG. This is the ready reckoner. Simply write what do you want. You want two sub branch line coupler or hybrid ring? Which component you want? You name it. Then give the ABCD parameter. Then it will automatically calculate S parameter. Here I would like to say there are so many excellent application notes. 154 is very important. That 30 page will make you get 2 degrees, 2 PhDs, and this will simply type it. A civil engineering student can type all those things. What is very important is layout will come. Layout will come up to the millimeter design. Don't you think that this screen speaks high? If you want to do this, you should be thorough in the theory. Theory is not a big thing like Maxwell's equations. It is a very simple thing, and it's a jugglery of ABCD parameter and scattering parameters. And you should be thorough. either in MATLAB or Python. But I strongly recommend become a strong person in Python. You can do wonders. So this, I I gave a big story at the starting, but this is some. Don't you think that 1 minute showing of this will tell how to make a beautiful layout? Layout, no? Take the printout, give to the technician. Whatever he uh, does using the methods of, I will show you how to do it. Then put the connectors. Connectors also not easy job. If Ankita allows, we can have one more session on connectors alone. Okay, each one is a ocean, but basically the fundamentals are very, very important. See, this is again, I learned a lot from IIT Kharagpur. That laboratory is this. And this is again, see, I have shown JC Bose. Now, I have listed out Indian women microwave stalwarts, not Indian, women microwave. So this is she's an actress, but she has contributed a lot for today's microwave wireless networks. What she has contributed, please look into it, or I will refer, I will send you the material. And now, why 50 ohms? 30 and 77, take geometric mean or harmonic mean, whatever mean. You will, how to get to 30 and 77? That is by this calculation. This is again lowest attenuation, optimum power. This is again pictorial representation of why to choose as 50 ohms. And this are all the connectors summary. You should know why BNC is called BNC. SMC, many you know. Type and APC, SMA, all the things. This is the summary of pages of the connectors, and this is more than sufficient to design any of the components what is kept in the defense corridor or BrahMos or ISRO application, anything. We normally in the second year we we derive what is the voltage at any point, current at any point. If you do that in the sending, Vs by Is, we don't call Vs by Is, we call in the transmission line it is a little different. Voltage and current, it is E and H. Anyhow, this you can keep on. Today you spend 2 hours, see what will happen. ZSC, ZOC, ABCD, everything. There is nothing that cannot be done by this equation. Gamma is alpha plus J beta. We never talk lossy, gold and silver if you use, and if you use high frequency, where is alpha? It is beta L. So hyperbolic will become trigonometric. You will get everything. Seeing is believing, working is enjoying. And this is again a small example. Even an antenna, if you want to know the input impedance, where to give the feed, don't go for a trial and error method. Pinpointedly, you say this point is the point. So again, you can use the same equation. In microwaves, whatever you do for impedance will come for admittance also. So that way, this can help you in finding out where is the correct point of location. Many things in antenna you can use with this equation. So this is again, the whole thing is in terms of ZOC and ZSC. If it is one, it will act as an inductor. If it is other, it will act as a capacitor. L and C is the whole thing. Antenna, we know. Computer know the equivalent diagram. Everything is in terms of equivalent diagram, L and T only. So these are the modes. Nothing more than this. And now my students, because my students, I go up and down. At one conference, they presented 4 different good papers. So for that, he congratulated. Not only that, he knows I was a student of Professor Bharathi Bhat. That makes him to talk wherever we see. This is the Maxwell's. Many is taught with the Maxwell's equations, but don't bother. We will not use Maxwell's equation. We use that and then uh, finish off this one. By birth, Maxwell belongs to Edinburgh. By personality, he belongs to Cambridge. By his work, to the whole world. These are all the 2 books. Whenever, until till you finish your PhD, please spend time. Again, I like IIT Kharagpur Library too much. All the original books will be there. Like that, there are some books, there are some libraries which are very good for microwaves books. And these are the IEEE books you would have seen. These are all IRE. Isn't it? During the merging 1960, why I'm showing now and then IRE is locate all those and you can see original write-ups. Varian, Varian, whatever when he wrote about the klystron, that like that original things you can see, like Mason's photograph we know, but what Mason wrote that you can see. So these are the original books, and these are the story. These are the history. It was founded in 1884. AAA, then 1912 IRE, then merging came in 1963. But now, what you can get in IRE papers, you cannot get in IEEE. You can show so many um, colorful mathematics, findings, all those things. But fundamentally, definitely nothing to beat IRE papers. Be thorough with IRE papers. And this I should owe to my student, Krishnagant. He got Rajnath called him and gave him an award. Only one application I will say, if you keep it on the flight, enemies cannot see. We can see. Many more things. Fibonacci number, first time in the world he did it. Very small boy, very young boy. He has now gone sky high. He finished the PDF. Well, he got one recently one award, and that award has been recognized and shown to all by the IEEE members. So this everyone knows, anechoic chamber. I feel proud that I have made two of my students establish the one and the only two anechoic chamber in South India. And this is another jugglery of this one, compressed smooth chart. Now, like Dr. Kalam, there is another boy. Anyway, that boy has not become president. He is now still at 28%. His name is Sandeep. It is his house. Whatever I have shown, jugglery of Smith chart, I will show you many more. Amplifier, oscillator, all those things were done in 2 3 days by Sandeep. I gave one challenge
Excuse
also
me,
to.
sir. Sorry to interrupt. Your presentation is not visible.
Okay, now can you see?
Uh, no, sir. Yeah, yeah.
Ah, previously it was a dark. Now this person is the editor of Microwave 101. On seeing the computer aided design miracles, he sent a appreciation note. And these are the mode. Many people do not know different kinds of mode even physically. And our students have done uh, CAD. Through CAD, we can get any mode, not only rectangular, circular, spherical, all those things. One should be careful in, one should be strong in mode. Then only MIC planar. So this is again a filter, entire thing. You mention whether you want low pass, band, whatever that, which material you want. Material computer doesn't know. It wants only what is epsilon effect or epsilon r. So what is the beauty of this is finally at the right hand corner you are getting layout. One of you please chat, give a type in the chat box why there is a metering, chamfering in the input and the output. Metering and chamfering will come in another version. It is called discontinuity. So that has come in some of the software, that is discontinuity will not be taken care of. So conventional is conventional. So this is the nutshell. Previously I have shown MIC components. This is filter. Filter, it's a separate. There's a book, a very big book, looking like a Bible, microwave filters by Mathai Young Jones. So this is your SIW, top view, bottom view. It's a bridge between. So one should be thorough with the waveguide. That waveguide you marry with the planar transmission line. That's how you have got the four equations. So that it is satisfied, you can use it in this SIW. This is our ordinary low pass tool. What you want to design is only two things, not even height. You have to design only the length and the width. Length is in terms of lambda, and width is in terms of and the Width is by knowing the Wheeler's curve. We have got two nomograms, Wheeler's curve and double nomogram. By that, you can easily find out what is the spacing, what is the lambda, everything. So RT duroid, you should know why RT duroid, why RT is called RT. Please type it. And finally, what you see in the left-hand side bottom is the final product, that is for S-band. And this is one is band stop filter, second is band pass filter. This is the usual lithography technique. These are all various antennas. Patch one antenna, one patch if you not sufficient, you can have arrays of left side, right side. If you go to the ISRO Trivandrum, you can see array. Or if you go to Uti, Muthore, you can see arrays of antennas. Many places, like your Pune, you can see not lotus garden, you can see antenna garden in the observatory. And this is what we want. Those who do not know, this is the Wheeler's curve, and that's an equation. And again, in IRE, there's a paper which will tell you how to get this equation. You derive the equation, then using the equation for each epsilon or each epsilon effective, draw this one. This will get you for any of the microwave material, you will get what should be the W for a particular Z naught. And H is, unless otherwise specified, you can always take it as 1 by 16 or 1.65 mm. And this is the new thing. The same Wheeler's chart, one of my students did in 3D one. Wheeler's chart in 3D curve. And this is the equation. One in terms of epsilon, other is in terms of Z naught. This, instead of using that, many go for microwave strip calculator, CPW calculator. That person may not know. I have gone for an interview for giving promotion. I have seen topmost people giving telling VSWR 0.8. So that kind of thing will come if you don't do from the basic and directly go for the commercial software. These are all for various W by H. This is for a final person, civil engineering. So directly you just to feed it, you will get the output. And this is goddess of, I call her as the Mother Teresa. We lost her also recently. Why I am showing this is biological effect of microwaves is another version. Microwaves play a very big role in curing the cancer. She was the founder of the biggest cancer center in India. And now the accomplishments of Jagadish Bose, all these people. And here you can see S.N. Bose also. You should find out, Google out what S.N. Bose has done. And these are all the uh, institute, which you can even now see in a different way. This is the book, Microwave Integrated Circuit Component Design Center book. That is the outcome, or what is mentioned, that only I will be telling, or what I am telling will be in that book. But what I got is entirely from some around some 30 pages from the first book of Professor Bharathi Bhat, Stripline like transmission lines. I will show the left side, right side, or the books of my hobby. What is the FSS to do in biomedical engineering? So that, this is the first one. Strip line, they call it a triplate. That was, this book was that heritage book. And this is the Bell Lab. These are all Bell Lab. See, this is not to get a applause from you. I have drawn a heart. If you point out the above equation and join it, it will come as a heart. Take home message is, you should have a love toward this Smith chart. And these are the software you should do. You should use it after you get employed, not at the research level. Or you make a software. One Kharagpur person has done one Indian made software. This is the MIT Radiation Laboratory. Around some 30 books are there. Each is for one thing. I think volume 6 is for direction coupler. Each book is for one. Heritage books. MIT Radiation Laboratory has done lot. Siri Pilani, MTRDC, the initial growth because of the Amarjit Singh's visit to radiation laboratory. So this is available in IIT Kharagpur in some of the good libraries. And this is the one. What is the 1, 2, 3, 4, 5, 6 of that lab? Then another kind of reference, advances in microwaves. 8 volumes are there. Then Bell System, a technical journal is there. Hewlett Packard, especially the application note, those are the reference in the best books. Especially we want application note 154. There are some more than 3,000 application notes are there. You can easily find out. This is another Bible, Waveguide Handbook by Markowitz. If you have that, any type of discontinuity can be done. Isn't it? It's a really wonder. The left side is the book of that advances in microwaves. This is how we play with MIC. These people only did it, that Smith chart and the cake. It is not a printed one. It is something, a brain behind that is one person from Rajasthan. He did it. These people did that. And what you see, the oldest person is Rode. So Rode and Schwartz, Hewlett and Packard, and the youngest person to my right side, one of you can type in the chat box. He's a very popular person in antenna propagation. So this is again by that boy. You have to expand it. If you expand, each one will become a Smith chart. So this is made up of so many Smith chart that is engraved inside a compressed Smith chart. These are all the MIC components in S band. Now, whatever may be the component, the principle of designing is very same. After 2 minutes, after 2-3 minutes, I will give you a break. Then after coming after the break, I will show you the design of any one. Only thing is you should find out what is even mode, what is odd mode, even mode, odd mode analysis, and then ZOE, ZOO. Using that, you can easily find out. However, there is no other component other than that. Now you rig it up and make it as a system. If it is some other place, it is in millimeter wave. If it is ISRO defense, it will be in gold and silver. If it is in our college, it will be ordinary brass or like that. So that only is differing. Frequency will be differing, but not the component. These are the different kinds of antenna. One of you can type in the chat box, what is the speciality of making circle instead of rectangular? Why we go for circular one? Then you know Yagi Uda antenna, isn't it? Yagi Uda, both Japanese people, and everything. The distance or land, each element is in terms of lambda. Everything is RFID. Then one is a power divider. The second one is both are all are power dividers. Each are of one is triple circulator. Then this is the directional coupler. If you make it is in a MIC form, two stub branch line coupler. If it is exactly power division, it is a 3 dB divide. And there is one um, coupled backward wave oscillator. You can have any number, 1:2, 1:4, 1:5, anything. That way you can have a power division. So these are all the components. Band stop, low pass, band pass. All the things. Now you rig it up. You can get a system. So make a small lumped element. You make it work as an oscillator or a mixer, amplifier, oscillator like that. So this is the one hybrid ring balanced mixer. In this, so many components are there. You should rig it up correctly. This was my project. Did 50, 60 years before in ISRO, when Dr. Kalam was the project director of SLV3. So what do you want? What is the length? What is the width? This is what the final product. This is what in the low frequency we call superheated and receiver. Here we say mixer. So I will stop in another 1 or 2 minutes. So you should see vary on. Everything from the horse mouth you should learn. You can may not know, you may not contact them, but at least their literature you can read it. Now this is for our research scholars regarding computations. No one believes them except the person who made them. Measurements, everyone believes them except this person is those who are really good computation, they can do it. They don't need any instruments. Otherwise, if you want to have an easy life, go for measurement. There's a wonderful book written by Ito about the measurements, different kinds of numerical techniques for MIC. Sorrentino also. These are the only two books. These two sentences are being told by Monk. His book is the one and the only book apart from KU for FSS. These are again, so these two things you should know. Uh, Now, substrates. With this, I'll stop. I wish all of you return back after 5 minutes. Anything you want to share, you can put it in the chat box.
Attendees, if any one of you have any questions, please put up in the chat box. We are taking a 5 minutes break, after which Dr. S. Raghavan will have your questions. Yes, Dr. Raghavan sir, we'll continue with the session now. You may please present your screen.
Hello, can you hear me?
Yes, sir, you are audible now. Sir, we have a few questions in the chat window. Would you like to address it now?
Can you hear? Are you able to hear me?
Yes, sir, you are audible.
Okay. You please ask.
Okay, sir. First question is from Sanu Roy. So, sir, he's asking, while designing mixer for SLV, how did you work on for identifying the shortcomings in your design, since full wave simulation software did not exist?
See, for the mixer, first of all, you should identify all those components, like two stub branch line coupler in the circular form, then stub matching for the diode. Two diode, nonlinear diodes have to be used. Each component you decide, then connect it. And then when you do the measurement, if there are some shortcomings, then you can go for metering or chamfering, taking into account of the discontinuity effect. Very rough way, what we did was we simply scratched it using a ordinary sharpener. But the other method of doing is you can methodically find out at which point you should start, at which point you should end. Angle, everything is given. If it's a microstrip, about full discontinuity points are given by T.C. Edwards. Likewise, in CPW, coplanar waveguide, R.N. Simon's book is there for knowing how to take into effect of the discontinuity. So, discontinuity only may be the one that will hinder the practical value from the theoretical value. Every component should be defined properly, decided, layout should be done properly. First, you can go for single band, next double side band, like that you can keep increasing. There is a book, Architect publication, exclusively for mixer.
Okay, sir.
Next one.
Sir, we have one more question. I'll read it out. It's a bit lengthy. Please hear it. So, for a coaxial feed microstrip antennas for GNSS applications, some designs were identified using UFL connectors instead of SMA. In such cases, we can consider for coaxial probe feeding during simulation, and whether to consider 50 ohm SMA connector dimensions or UFL connector dimensions, or finding the coaxial dimension by considering air as dielectric. So the person is asking some insights regarding it.
Okay. See, there is a theoretical paper is there, or I myself have a good PPT on connectors. The reference is Hewlett Packard. So there you should refer and then choose accordingly about the coaxial or whatever. Nothing like Gaganyaan or the application. What is the kind of output impedance like that? Now, not for application oriented wise, one need not go for the connectors. Just like any other microstrip antenna, like suppose if you are going for the biomedical antenna, again the division is design is same only. Only thing is the material to be used is the one which should be compatible for in body, or what we say is compatible. So that way the design will not get changed. The materials and other application, the other things will get changed depending upon the applications. Again, some more information you can get from the this lever data on connectors.
Okay,
Okay,
sir.
shall I proceed?
Yes, sir. Please proceed.
Okay, um, we need a epsilon effective. Epsilon effective calculation is not by quasi-static method, only full wave state. So these are all different variants. Microstrip, you can turn it other way also. You can suspend it. You can have the advantage of both, air advantage, planar transmission line advantage. Now you can turn the slot line in the 90 degrees. We don't say 90 degrees, keep it in E plane, then you have as a fin line, just like fins of a fish. Now suspending, whatever it is, different transmission lines are there. What we want is how to find out the epsilon effective. So this is what the nutshell of the previous person's question, nutshell of all the connectors, then a different profile, including the waveguide, CPW. CPW, if you take the complement, you take the CPS. And this is again little more than centimeter wave. Microwave will become millimeter, and we call it as a millimeter wave, above 30 gigahertz. And you should find out why this peak for a particular frequency alone, H2O, O2, H2O, this, we call it as a windows. Why the windows come? So you should take into account of that and go for the millimeter waves. So nothing to beat the conventional antenna. Everything is best in this kind of antenna, but you cannot imagine this kind of antenna on a satellite or a implantable one. Miniaturization, you should go. When you go to miniaturization, everything will be satisfied. Only thing is power will be different. So only we go for different kinds of antennas. Profile also, if it is there, I will show you. So in any case, we want the miniaturization. Now this is all the connectors, all types of connectors. Just for easy understanding, I put it in the guest book. This is first book. Strip line like transmission lines, fire microwave integrated circuits. In this, all the fundamentals are given. 30 pages are there. That is sufficient for everything, for every operation, the design of the MIC. If we can do for microstrip, the same can be done for strip line, inverted, everything. What differs is the cross section and also the method of finding epsilon effective. This again, Bharathi Bhat New Age publication. These are all various. These are the things. Entire filters. Here you can have the discontinuity is not a negative thing. like a nuclear fission, you can use it for good purpose as well as bad purpose. Likewise, step discontinuity, step up, step down, then gap discontinuity, bend discontinuity. So here you can see band stop filter. Here one small corner, that is what I told, metering or chamfering. So that you theoretically do it, then slowly remove certain portion, then you may get the exact practical one coinciding with the exact one. These are the different types of filters and their layout. This layout remains same every planar transmission line. Only thing, the length, physical length will get changed, physical width will get changed, and cross section also will be different. See, if it's a coplanar waveguide, everywhere you will get up and down uh, the earth point. So these are the books, Mathai Young Jones for filters, everything given in filters. Then other one is, again, this is written by K.C. Gupta, Ramesh Garg, Kharagpur professor, uh, his book. Then the other one is T.C. Edwards, and this is fully Bharathi Bhat book. What he found, pin line found by Mir, but exhaustive work have been done by Bharathi Bhat as her scholar Raghu Kumar, like that. The left side, right side are CAD techniques of pin lines. The left side, left more, many do not know or use it. BC Waddell, any planar transmission line, not only the known, whatever may be the planar transmission line, you can find out, especially the beta. Beta, if you find out, that will characterize almost everything what is wanted. Effective one. The next one is CPW by R.N. Simon. Again, he was a student of Bharati, but the next one, Harley and Ho. Harley and Ho, I showed that was his only book on stripline circuit design. And I want to tell, if you want to be very strong in microwaves, you should be strong in network theory. If you are strong in network like image impedance, iterative impedance, the T network, is whatever may be the network, it is all made up of by single L section. That you, if you connect it in this way, you will get a T network. If you connect the bottom one, you will get a pi network. All the networks are based on this only. Based on, so first of all your electromagnetic theory, you convert in the form of a lumped one. Isn't we say VSWR or matching. That is what in the low frequency people say maximum power transfer theorem. So you bring out even T10, T, everything you can make it in the form of a lumped network. Lumped network, you just play like a network theory. So you be thorough with network theory, especially rider first portion you be thorough, then everything will become clear. So these are the things, how to find out OC, how to find out SC, all those things. So if you take a patch antenna, don't simply don't need to see previous papers to know the length, everything. First, for the patch, you find out what is the impedance. For the input, you take it as 50 ohms. If you want to connect that, then you use the Z0 square equal to ZS into ZR. How to get this equation? That is also again by the transmission line equation. See, now you are getting 0.05 lambda, 0.003 lambda. So what I am telling is length is in terms of lambda, width you should find out from the Wheeler's curve. And this is again, you should properly get distributed. So every point of distribution should get satisfied with Z0 squared is equal to ZS into Z0. So this is how you can make use of the feed by a square patch, either by the branch line coupler or the one what I am showing here. Lambda by 4 plays a bigger role. Now most of the people, they use this delta L. Delta L, this equation comes, but how it comes, one may not be knowing or one will not be interested. You should take care of the Hammerstead paper. That is the one BL, one type of material I will just show you. From there, the Hammerstead equation has derived this. There is no antenna paper where the correction length is given by this. But one should know how to get 0.3, 0.264, all those things. How to get epsilon effective from simply epsilon naught. That varies from each of the planar transmission line. So this is what I already told. And this is for the immittance chart. At the same time, you can do for series as well as the shunt. Isn't our amplifier is very easy. Not like a low frequency input matching network, output matching network, series and shunt. If you want to do at the same time, go for this one. And this is the four types of charts, four types of circles that completes the entire microwave amplifier and oscillator. If you design amplifier, don't remove the input, not just like that. Take care of the other kind of connections, and then it becomes an oscillator. See, you should write a constant gain circle, then stability circle, then noise figure circle. All the circle, it is all in the form of x minus a squared plus y minus b squared is equal to r squared. That makes the entire thing very easy. A simple equation, but little different of this. So anyone which is little difficult, to make it in a one which a person likes. So these are the different numerical techniques needed. One should be thorough. The person whom I told, R.K. Mishra, he has done everything he used to do without a computer. FDTT, MOM. Only thing is, I have seen nothing much has come out from method of lines. If you want to know in detail of all these techniques, take Ito book. And this is just, I have never showed, I have never talked about Maxwell equation here. And this is the appreciation of, one should be very good in two-port network. In ordinary network theory, it's a two-port network. Whereas here in transmission lines and microwaves, we take VS, IS, VR, IR. We talk in terms of scattering parameters and not at all H parameters. Again, application note 154 will help you a lot. And this is the nomogram, either the Wheeler's diagram for a single parameter you need, or this how to draw this nomogram. You should again take that Zipline design made easy book and then draw it, then apply it. Now this is one example. Automated. This is not the calculator. Simply write, fill up OE, OO, AR, automatically it will calculate epsilon effect, everything. How it automatically calculates? One should be thorough in the theory, then do the programming, then find out its width and the spacing. This is required whenever there are two patches, and these are all must. Only there are four things: series impedance, shunt admittance, lossless transmission line, at the most a transformer transmission line. All these things we should know the ABCD parameter. And this is the combined one, nutshell of the image impedance to the scattering parameter. And this is the layout. Simply feed. This was done by our student, the same person who house was like a hut. He has done this. It is not he. Whoever has got a bill, they can easily do. Just to fill up the order of the filter, epsilon effective, frequency, where the material, all these things, you get the layout. Take it out, give it to a technician, he will find out. Especially microstrip, Trivandrum, VSSC as well as the SAC Ahmedabad is too good. Institution wise, I have seen in IIT Kharagpur, IIT Delhi, they do a lot in this fabrication techniques. And these are all the ABCD parameters. These are all available in Poser book, and one should know about Richard's transformation. All J tan beta will replace it by S, and this alone is sufficient to get a impedance, to get an inductor, to get a capacitor. What more you need other than inductor and capacitor, either for a antenna or for anything else? And this is a low pass filter, the other one is band pass filter. This is a hybrid rat race. Now I will tell you how to do the design. Design is very easy. See, now one easy work done for the micro designer is MIC designer is, whenever you find a symmetry, make it into half. Then the one what is separating we call plane of separation, electric wall or magnetic wall. One belongs to short circuit, other belongs to open circuit. Now, if you make it into half, YA will become YA by B. It is always better to work with admittance than impedance. Now, if you make it into half regarding the 3 dB hybrid, there will be three ABCD matrix. And the same three ABCD will come for rat race also. We should know why it is called rat race. And again, it is not, it is the same three ABCD matrix. The ABCD parameter has got one more name called chain parameters. If you know the individual ABCD parameter, one person asked the doubt about um, the superintendent mixer. So individually you find out. then you combine, then you get effective ABCD, then use the conversion factor, and then get finally one scattering, like what we do with the reciprocity theorem, like that, not reciprocity, superposition theorem. So now here what happens is, in the rat race, if you make it into half, you get lambda by 8, lambda by 4, 3 times of lambda by 4. Only length differs, but not the other thing. Same YA remains, same YB remains, but lambda differs. So lambda makes the thing possible. So once you make it, make small, three, both have got 3 ABCD, and you just multiply, you get one effective ABCD, then convert into the scattering parameter. And same thing, coupling factor. Coupling factor is given in terms of ZOE in this value, in this relation 1 by C plus. How to get this? You should not simply take it out. You should know how to get C naught. C naught you get from ZOE minus ZO by ZOE plus ZO. Like that you get, then use Z naught, get ZOE, ZO. Once you get ZOE, ZO, you use the nomogram, double nomogram, and then find out how to find out what is the spacing and the width. In the Wheeler's curve, only W alone will come. One factor alone you will get. Whereas in the double nomogram, you will get both. Whenever that's a coupled line, you need to get both this width as well as the coupling factor. So these are all the nutshell of a filter. You need to find out. You might have studied in signal processing also. You need G1, G2, G3. This is what given very nicely. If you want to get it in a simple way, write it down. If you want to have a ready reckoner at the time of launching, if you want to know all those things, take the Mathai book, take the values directly. So you get what is S dash, all those things. Now, once you design a low pass filter, make all inductor to capacitor. The numerator S should come as the denominator S. Band pass will become a band stop. Resonant should become an anti-resonant. So that's why you get all the circuit. Then Mason's flow graph, this alone is sufficient to find out all the types of amplifier. And when it will become PV, AVS, BM, this flow chart will give you all the things. You should know how to draw the flow chart of a scattering parameter. Then you give the generator and take the load and draw the flow graph and get this Mason's flow graph and get all the values. And you know Corona identity. That is needed to convert series impedance into shunt impedance into. So all the fundamentals are required, and best book is the Pozar book is sufficient. So this is again computer aided design of filter. It will ask what is you want, low pass filter or high pass filter. You enter the option and enter the order of the filter. It is always good to give odd number only, not to give even number. If you give even number, left side looking will be different from right side looking. So give always odd number, minimum odd number. Then give the cutoff frequency. Then the dielectric of substrate. Simply it is asking epsilon r, but it will program will calculate 4.8. I'm not telling this as a this is what the height of the substrate always 1.6. But if you tell the organizers, the manufacturers, you can get 1 by 32, 1 by 8 also. If not, it is 1.6 mm. That's what we standard 1 by 16th of a inch. And 4.3 you get you give automatically, you will get what is the G1 values, then length you will get, width will give, height it will take care of, the final layout. So this is the computer aided design of any of the, not necessarily a filter, any design. The antenna is only one length, one width. See, in filter, that's why I always say, if a person is thorough with filter, all other components designing will be very easy. It will be a child's play. So filter be thorough. So for filter to be thorough, no need to take a big Mathai book. Take a writer book. First half book, be thorough. Make use of the equation. Yeah, Z naught squared is equal to Z1, Z2. Then everything. Inductor capacitor change. It is all simply, it will you can keep developing low pass, high pass, band stop, all the things M derived also. And this is the jugglery with amplifier. See, what you have to give is only S11, S12, S21, S22 only. In ISRO, for these things for feeding, only plus 2 students sufficient. Only you have to feed only scattering parameters. Scattering parameters the engineer should design from the effective ABCD parameter, and simply feed S11 with the angle. Then you will get everything. First of all, you should find out whether it is stable. For that, you should be thorough with the Rolex paper, Rolex stability factor. First of all, you make it stable. If you want amplifier oscillator, you don't make it stable. Then get all the dimensions. Then you need everything. You be thorough with the fundamental principle. You will get stable region, unstable region. This is again compress the Smith chart. Compress the Smith chart is mainly useful whenever the reflection coefficient goes more than one, isn't it? Definitely for an oscillator, reflection coefficient will get more than one. That time you don't need to go for. You should go for compressed Smith chart. Suppose if compressed Smith chart is not there, if you know the theory properly, then what you take is take the reciprocal of reflection coefficient, take the complex conjugate, ordinary Smith chart, you can use it for that, isn't it? These are all not needed when you go to ISRO and do it, but as a designer, you should know. As a researcher, you should know. So this is again, see what is happening to the 3D Smith chart. Everything will come with little more detail. See, this is again impedance chart. You should know what is the length, what is the width of input matching network. Everything you get on a single scene. This is looking very neat, but definitely with a strong theory and very good Python or MATLAB, you can easily do it. This is again all those things. This is again the frequency selective surface repetition. Again, frequency selective selection means what? It is filter only. Filter only. It is filtering the frequency in a surface way. It is in the space way. There it is not like that. So this is regular repetition, and now it is getting momentum. Isn't it? In India, if you take 3 4 people, again the equivalent circuit, Deepak Sood of Kurukshetra University is the one, likewise Shivanarayanan. Like correct, I can number. I can definitely say Krishnakant is one of the very few in the world. See, he is the person who receives everyone. See the recognition a person gets if the research is very good. The research you do should not end with journal paper alone. It should go for the societal value. Many people of my student or biological effect, everything I've done for the societal value. So this much recognition got, then immediately Queen's University got, he finished the PDF, then he is given 3 years free visa, going anywhere and doing academic work. And again, my student left side, the person who is there is CP Ben. Why I keep telling all this thing is that CP Ben paper, 1969, from that you start, it will be on CPW. The right side young person, you know, very often he comes to Kharagpur everywhere. Bosi. Bosi was the examiner, or Pendry was the examiner. He returned the thesis of Krishna Gandhi in 2 days. He excelled MIT person, he excelled IIT person, he excelled NIT person. In 2 years, 10 IEEE papers. I do not know whether there is any person who has crossed this. And this is Rajmitra. Like T. Ito, Rajmitra also is too good on computational electromagnetics. This tallest person is the PDF guide of your R.K. Mandal, Dr. Mandal, M.K. Mandal. He is KU. And this is any component, most of that will be, even if it is not symmetrical, you can make it to half and then do, but most of the components used will be a symmetrical one. If it is asymmetrical, there is another method like isotropic and anisotropic. That is again different way you should do. Now you make it into half. Now the parallel coupled back waved coupler also you make it into half. Here the bottom one designing is little more, little easier than the other one. So make a you should define what is coupling coefficient, insertion loss, return loss, directivity, all those things. And many of you should maybe knowing why the directivity is infinity, why there is no power coming there. Again, by lambda by 4 makes the thing possible. In one it adds, in another it subtracts. So the basic of the reduction coupler you should know. Then two sub, now you just divide it, you get OA, YB. Now when you shunt it, the left side, right side will be YB by 2, YB by 2. Now you make it an electric wall. If it is an electric wall, you should take ZSC, JZ not tan beta L. If it is a magnetic wall, open circuit, it is Z not by tan beta L. Beta is 2 pi by lambda g. Lambda g is equal to lambda naught by root of epsilon effective. That takes care of all the planar transmission line. Length is the lambda. So you will get a very nice summary of scattering parameter. From the scattering parameter, for any coupling coefficient, you can find out what should be the width. Length is always lambda g by 4 only. Width get differed depending upon the impedance. So this is how you get make it into half. You get open circuit, short circuit. One is called even mode, other is called odd mode. Now take 3 ABCD matrix, and now you see metering is coming. Metering or chamfering, why? It is not simply cornering. At what point it should start, what point it should end, exact formula is given. I am very happy to say that I have found out 16 discontinuities in CPW. Microstrip discontinuities, you can see it from TC Edwards, but this one you can get only from the paper. There is nobody who has found discontinuities in fin line. You find out, let it come in the form of a paper. You try FSS. So now see, just from what they will tell is what is the coupling coefficient. Design a couple branch line coupler for 32 dB. From 32 dB, you will get S13. Now use the S parameter property, unity property, zero property, reciprocal property, all those things. Then S13 only you will know. All other things you have to find out using your basic property. Once you get all these S13, S14, now you will find out how to find out impedance. See, ABCD left side red color, right side another red color, and center is just like any other transmission line. So it is cos theta. That is theta is beta L. Lambda G or lambda both are same. That is epsilon effective. That takes care of for any transmission line, like our microwave experiments. The setup is same. Only the method is different. Everywhere, source, directional coupler, isolator, VSWR meter, load, everything is common for all the experiments. Method of doing it, in 1 or 2 minutes you can finish it up, but you should be thorough with the theory. So generally find out effective ABCD, get one scattering parameter, then from the given specification you find out which you got it, then use the S pattern, then get the things, then find out. See, this is how, this is a nutshell. If it is a even, all the top one. If it is odd, it is the bottom one. Now, definitely a good microwave engineer will see that input is perfectly matched. If the input is perfectly matched, S11 is 0. S14 is 0 because at the fourth port there is no power coming. Because of that, S14 is 0. Now, if you take the row S11, S12, S13, S14, among these, 2 are 0. Now, S13 is given specification. Will it be difficult to find out S12? Now you get YC by YA, YB by YA. YC means many books refer as a characteristic impedance. I normally write it as Y not only. Now, this 4 lines are sufficient to design a branch line coupler. To have to overcome the discontinuity effect, you have a circular one. That only is found as one of the major component in the mixer. Now see, nutshell value is given. Now once you are deriving this, now put it using your mathematics, MATLAB skill or Python skill, make it as a ready reckoner. Now see how to do it for a strip line. The only difference of strip line and microstrip is there you should use epsilon effective. Here you should use epsilon r. There it is a inhomogeneous. This is a homogeneous. There it is a pure TM mode. Here it is a quasi TM mode. That's all. but the formula remains same. So this is the one. If it's a 90-degree coupler, 6 dB, 3, 6, 10 dB, what are the final values? It is not the beautiful numbers 3, 6, 10. You can have anything 13.3. Simply get S13, get S12, get all these values. Now you can easily find out the impedance. Once you know the impedance, you should use the Wheeler's curve for the particular epsilon r. Then you will get the width. What about the length? Length is lambda g by 4. Now, if it is a homogeneous, use epsilon r. If it is a inhomogeneous, whatever it may be, fin line, use that epsilon effective. And now these are all the additional theory. Now, if you want to have more, then you can connect it, but you cannot keep on increase. That's an optimum number, just like a multi-cavity klystron. You cannot simply add the number of cavities. That is some optimum value. Similarly, here you can add 2 or something optimum. Then this is again, this again I will give to 13 pages, 30 pages of that strip line transmission line book by Bharathi, but right away it is given OE plus OO, because you are making it half. So the half should be added. So sometimes it will be subtracted, sometimes it will be added. When it will be added, you should know the feeding point. If feeding point is both positive, you should add. If one is positive, negative, how to design positive, negative, whether it is a even mode or odd mode. So this is the nutshell result. So hybrid ring, this is the only way it is different. There, everywhere it is lambda by 4. Here it is 3 lambda by 2. Isn't it? Just like what you see your ferrite. Ferrite, if you use inside a 3 cavity one, it will not be an isotropic one. It will be an anisotropic. It is S12 will not be S13. So for that you should be thorough with the basic theory. So this is the one. The process is exactly same as the hybrid one, except that here it is 3 lambda by 2. Now put it again in the form of if it is a power divider, it is 1 by root 2 will come down. If it is other than 3 dB, it will be any other value that you should find out from taking anti-log of S13. And these are all the final value. Take exactly half, make it single ABCD parameter, get the two value S12, S13, and finally afterwards you can get the frequency response of any frequency, mid band, left side, right side. You can find out all the responses. This is the strip line. How to get so use this my how to get this. Again, go for the original paper, strip line like transmission lines. See, these are the same principle you follow. All the passive components can be done. Low pass, high pass, band pass, directional coupler, power splitter, power combiner. Splitter, left to right is splitter, right to right, left is a combiner. Circulator, isolator, attenuator. Attenuator, again, the circuit theory only, the network theory, Everett and Anner. For any, there's another book by Royal Signals, military book. For any of the decibel, it will tell you what is the value of uh, resistance value. Resistance, we call it as an impedance. Resonator. So all these branches. Antenna is the smallest one, simplest one, not like a filter, multi elements. Simple one. Then you can add. Then different types of antenna for the different applications are needed. For that, you should know that theory, isn't it? This is the exact fabrication done in some a particular brand. So backward coupler, you should know why it is called a backward coupler. Just like a TWT, we go for BW also. The MIC version is this one. You can easily find it. You should know what is the spacing and the width. That you can get it from ZOE and ZOO. Again, use this another technique and find out how to find it OO and OE, parallel coupled one. And why it is called backward coupler, you should know. And analysis, you can find out, get the values. Power dividers, it is simply easy. No need of big kind of analysis. You should get divided by 2. There are two methods. One is left side and right side both are Z0. Then you take square root of Z0. The second one, a little different. One is root 2 Z0. Root 2 Z0 means impedance is high. If the impedance is high, if you see the Wheeler's curve, the width will be higher than the width will be lesser than Z0. Suppose if it is Z0 by root 2, the width will be more than Z0. So that is what this. It is the width is Z0 by root 2. Whereas the previous one is not into root 2. So you don't need to remember in the sentences what I am telling. See the Wheeler's curve and then do. So this is what the component and what you can do the characteristic. What are the characteristics? Just like antenna, you got so many parameters. What should you do for microstrip line, ring resonator, 3 dB, rat race? It is not race, rat race hybrid. Brand. What are these? Are the measurement parameter you should find out. And another thing, if you want to have different ratio, then you can go for this. This may look little bigger, but everywhere you should satisfy Z0 squared is equal to Z0, but length remains same. Z0. So suppose if there is a isolation resistor, then it is you call it as a Wilkinson power divider. If not, you call it simply a power divider. So these are the methods, and I think with this I will just conclude, and I can just give the reference. Everything you can get it from that strip line like transmission lines, because that has been used in all the projects, not simply theory. Just the 30 pages you can get. Then application note 154. There are many applications, 6 applications good for us, but 154 application note will do. Then please go and browse microwave 101, go to the radiation laboratory series, see IRE, and find out the original golden classic paper. SB Kahan paper you find out. CP Ben paper you find out. Rowlett stability factor you find out. Rowlett paper you find out. Mason's holograph. Mason's thing you find out. TC Edwards. Then Harley and Ho. Harley and Ho, you will get everything. Aaron Simon. So like that, you go to the original paper, make yourself thorough, be confident, and then once you finish off your PhD and then go for the job, there you go and keep utilizing. Or even now you can do manually all the things, then verify it with the software available. If not, people may not know what is the basic even. Isn't VSWR? What is standing in that? Voltage standing wave ratio, what is standing in that? Likewise, another question many may not know, we use C is equal to F lambda, isn't it? That is actually velocity of light. Instead of V, why C? C is equal to F lambda, it should be V is equal to F lambda, no? But why C instead of V? So you just find out, or if you know, you can tell or put it in chat box, your organizer will tell why we use C like that. A dB, you know, decibel. Many do not know why bell, and if not decibel, Nepper. Impedance makes why hybrid parameter is useful, because we don't need to conduct experiments. Simply by knowing the impedance, you can predict everything. Likewise, here if you are good in certain things, you don't need to conduct the experiment. Before that, you can do pinpointedly. No need of a trial and error method. It's a Nepper. One is a natural logarithm, other is the common logarithm. By that, you can easily do the attenuation. You can easily find out the impedance level. So that way, fundamentally, you please make thorough and enjoy MIC. So now you got a terahertz. Terahertz, now people have got a 5G cell phone. In that cell phone, we got coplanar waveguide ground at the bottom. It is called GCPW. GCPW is a very good candidate for millimeter wave frequency apart from fin line. So now, but apart from that, one should try to do what is the bad effect, biological effect of microwaves. Again, Indians stand first. Our the topmost book, biological effect of microwaves, written by a person like Gujarat, like a William Sunita Williams, O.P. Gandhi. So that way, we stand first, and fitting proof is the marvelous work being done. One of the application done by our space applications. As and when our satellites go up and up, our value goes up and up. The whole world see India at the sky level. So please, it is very easy. I have not talked about Maxwell's equation at all. Simply that small equation, ABCD parameter, S parameter, all those things only. So start enjoying that. Let your paper be of societal value and not stop with the journal paper alone. I thank everyone, and particularly Ankita Biswas and Roy and all the organizers. And there are many people who will talk from the basic, like R.K. Mishra, J.C. Bose, this B.N. Basu. There are many people. uh, they will easily derive FDTD, so many things, fractal antenna, regular repetition. So please call such people amidst your already planned topics. I wish you all the best, and see that your journal papers reach sky high. Thank you very much.
Very thank you, Raghavan sir, for coming to this talk, and you have delivered a very wonderful speech, and every one of us have learned a lot from this session. If I have asked the participants if they have any questions, so we might be taking those as well.
Yes, please.
Hello, sir.
Yes, please. Yes.
Sir, I have one question. Sir,
Yeah.
can you please explain more detail about this NRT guide? Actually, I couldn't understand this one.
Explain.
About this NRT guide.
NRD. Yeah?
NRD guide.
Okay. NRT guide, actually, it is little away from, it is deviating from the topic. NRD guide is a non-radiating dielectric guide, and the person who found Dr. Yoneyama around some 75 years is still there in Japan, and see, we go for the you take an ordinary waveguide, and if you simply leave it, then it is a homogeneous media. Then you fill it up with dielectric, then it is called the dielectric guide. If you use NRD, there are so many variants which you can do, like this, like image guide, inverted strip guide. So you can easily find out the difference between the dielectric guide and an ordinary guide. So if you take a dielectric guide, the modes will be different, the cutoff frequency will be different, the method of propagation will be different. The same NRD, you try to do all these shapes what you are seeing, inverted one, invert, RDO, then it will have a more. Then you can put inside. So if you put that, the one advantage is you can work. See, the mode itself is LSM. See, LSM mode. It is now LSM mode, LSC mode, not like what we talk so far as a T10 like that. The This is all a very good candidate for higher frequencies, for more frequencies, and some more you can get from this book. Again, the person written is the first scholar of Bharathi Bhat, millimeter wave and optical dielectric integrated guide. So NRD will play a greater role in millimeter wave, millimeter in the sense even at 225 gigahertz.
Mm. Does it support terahertz range also?
Yes, yes.
Okay.
And for certain things you can combine, isn't that is what like micro electromechanical system, air is not lossy one, but you need planar transmission lines, so you mix both. That is why the cross section of NIMS is simply air, you remove the substrate. Similarly, when you want to work for terahertz, the terahertz property should get satisfied, the original geometrical property should not get altered, other inner property also so you should combine um, all those things and have a cumulative effect, and that way you design. And terahertz itself is different. See, centimeter microwave design simply you cannot extend to millimeter wave, isn't it? Whatever you have in the 3G and all that antenna, directly you cannot go for millimeter wave. You should use different techniques are there. The 5G, 6G, and all. The packets are different, so the design principle little differs from millimeter because of the microwave windows. So it is not like your centimeter wave. Similarly, terahertz has got some more limitations that also you should take care of that.
Mm. Okay, sir. Thank you. From the audiences, if you have any question, then you can unmute yourself and ask to the professor.
Yes, please. Actually, the more you yourself telling, um, the conversion is very less. Conversion very less shows that the probability of your work getting accepted is more. Suppose if you get plenty of, suppose if you go for discontinuity in microstrip, books have come, so there is no use of prolonging that. So what you are telling, it is nice that you are writing, attempting to write your own code to magnanimity. And if you see that it is a less number, then it is a positive point only. Then what you do is you write in your own code and get a product and get the output. Now you try it with the commercial software. If it coincides, then it shows your work is successful. And again, one cannot believe that commercial software is 100% correct. So if you are satisfied with the way in which you are proceeding, you can make that difference itself as a challenge and make it as a paper.
Any more question from the audience? Okay. So, thank you, sir. Thank you for accepting our invitation. It was a very informative session. We are very fortunate to have such knowledgeable content in this talk. So, we will be proud if you visit IIT Kharagpur campus someday. if possible.
Thank you. I have come many times. I think one of the hostel name itself is Esan Bose. Many times I have come there. In fact, Samir itself is the birthplace is Kharagpur only. So definitely, I will make use of the next golden opportunity to come to your campus and see your group.
Sure, sir. Sure, sir. Okay, sir. Thank you, sir. Thank you, all the audience, for being part of this event. Thank you all.